Good evening, everyone. Welcome to the video on misconceptions in physics. Let me just share my screen. Okay. My name is Ratankar Rao. I teach physics in one of the international schools. And the target is to make 365 videos in 1 year. There are several video channels which are available. But the interest in this is to understand a student's problem while he solves numericals. And towards it, I had been in this field, the teaching field, teaching various types of students from as least as from 9th standard to until MTech levels. And while I was teaching, I observed that some students or most of the students would stumble upon certain type of problems, and many of them make a mistake on those problems. I just marked all those problems and kept it across. And then I found why they made a mistake. When I inquired them, they say that there are some concepts which are very similar, and I thought of probing into those concepts, okay, and then try to understand why they make a mistake. And the result is we have this set of problems. So I think as of now, I have completed so far around 98. Yesterday was 98. I think today it is 99. 99th problem, and tomorrow will definitely be a century. Let us see that I will complete 365 days. Do share and subscribe to my channel for all these updates. It would really prove to be an encouragement to me. So towards it, we had already completed around 7 chapters. The chapter that I am looking at is the rotation, which is the 8th chapter for JEE mains. And of course, this is a chapter which is present even in engineering physics for the students of IBDP who take up the elective as engineering physics. Well, this is one of the most toughest chapters for all the PU students, 11th and 12th, people who are looking for JEE mains, advanced, and so on. The reason is because in order to understand this chapter, the concepts which you study in your mechanics complete should be concrete with you. If you miss any one of these concepts, you will not be able to solve problems in this chapter. So that's why most of them, they just skip this chapter because they feel they will not be able to attempt it. Okay, now enough of my introduction. Let us begin with the chapter. Right. So we had been doing problems based on this. Now let us do one more problem, which is on angular momentum. Now, what is angular momentum? You all know. I'm not going to teach the concept here. So angular momentum is nothing but moment of momentum, a very complex one. Okay, let us do one thing. Let us say angular momentum is given by the formula. Directly, let me move on to this. Angular momentum is given by a letter L, which is a vector quantity, which is nothing but vector R plus vector P, where vector R is a position vector and vector P is the momentum vector. Okay. Now, based on this, now this is a problem. It's a very simple problem given to PU level syllabus, not even JEE mains. Okay. A particle of mass m moves along a line distant h from the origin. Moves along a straight line, distant h, distant h, distant h. This is distant h from the origin, parallel to the x-axis. Since I know the problem, I already written it. Okay. This is my x-axis. This is my y-axis. What will be its angular momentum after 5 seconds? Now, the particle initially at t equal to 0, it is at this point. T equal to 0, it is at this point. Let us say at t equal to 5 seconds, the particle is at this point. T equal to 5 seconds at this point. It's going at uniform velocity. That's what we can say. Now, he is asking you, what is the angular momentum of the particle? Now, the student had taken the same formula, good R cross P. The direction of R, since these two are vectors. Now, see, this is a misconception starts. Direction of R. What is R here? R is nothing but the position vector. Now, the student does not understand the position vector because he says very clearly direction of R is along the x-axis. Now, what do you mean by position vector? Position vector is that vector which takes up the point, okay, takes up the point of the particle. Let us say a particle is at this point. Then you draw a vector starting from the origin. From the origin, if you draw this line, which is pointing to this particle at a given instant, this is your position vector R. This is your position vector. Then what is the position vector of the particle when the particle is at this point? Then you should once again draw this line. This is the position vector of the particle R2 here. Now what is the position vector of the particle? Let us say it is at this point. What is it? Then draw once again a line like this. This will be your position vector of the particle R3. Now you see, every time as the particle is moving like this, the position vector length changes, the angle also changes. Okay, very, very small, minute things you should know about it. So both of them change, right? Now, so the student made a mistake saying the direction of R is along the x-axis. He had assumed position vector means it should be along the x-axis. Many students do this mistake. Okay, so that's one thing. And direction of momentum is along the x-axis. Why? Because you see, this is momentum. What is momentum? Momentum is P is equal to M into V. The direction of V is the direction of P because M is a scalar. If I put M equal to some 3 kgs, for example, then what will happen is it will become 3 times V, which means what? If initial velocity vector is in this direction, this velocity vector, this momentum vector will also be in this direction. Only thing is when I say P equal to 3 times V, maybe this length would be much larger. That's what we can say. Okay. So therefore, the velocity vector is in this direction. So what he has done is he has got confused with this x vector, okay, with the r, and thus he said that this direction and this direction, which is this? This is your r vector and this is your p vector. These two are seen to be parallel. That's what he has assumed. Okay, and as a result of this, the angle between them is 0, and he has substituted r cross p equal to rp sine 0 equal to 0. And finally, he said, okay, this is what is the answer. So this is a misconception. Why this is a misconception? What is a misconception here? Not understood the direction of vector r. What is vector r? Position vector. Position vector. You see how basic things are very important. Until unless you make, there is some amount of flaw in understanding the basics, then definitely you will make a mistake. The advanced problems also. We always think what is wrong in this area. This is my very small concept. But still, this plays a very important role. The entire problem goes wrong. Okay, now let us move on to the correct solution. Now, what is the correct solution? Let us do this. A particle of mass m moves along the distance h. So once again, let me draw this picture. This is at a h. The particle is moving like this. It's in a straight line. Wow. Anyway, my teacher has taught me straight line properly, but while I'm drawing, I make a mistake anyway. Now this is m, this is velocity v, and at every point the value of r is changing. Value of r is changing like this. Let us say at a time t is equal to 5 seconds, the particle is at this point. Okay, this was your r1 vector, this was your r2 vector, this is r3 vector, this is your r4 vector. Definitely each and every time r is changing. Yeah, if that is the case, angular momentum, how do I find? Okay, it keeps on changing. Will it be along x-axis? You can ask how many questions. Let's see that also. Okay. Now, so what is my angular momentum, which is given by r cross p? Here, now I can say maybe one of the, maybe if you are doing it, or if I am doing this, if I not understood the concept correctly, then maybe after 50 seconds, the particle would have been here, and thus this angle would have been changing like this, right? And if I still go, okay, infinitely larger time, the particle would have been here, and then I would have drawn like this over. Okay, so now, so that means I will not be able to come to a conclusive answer according to the problem. Now, let us see whether we arrive at a conclusive answer or not. Now we say L equal to r cross p. L is equal to r cross p, and this I can write this as, this is nothing but a cross b vector, which is nothing but rp sine theta. Rp sine theta. R, we will substitute for p. I'll write this as r into mv into sine theta. Now what I will do is I will group this m into v outside, and then I will group this r sine theta together. R sine theta. Now let us understand from the geometry what is r sine theta. Now what is theta? Theta is this angle. Theta is this angle. Hey, how do I know this is this angle? Because you see, this is my momentum vector p. This is my radial vector r. Sorry, position vector r. Okay, this is the angle theta. So therefore, this angle theta is the same what you get over here, corresponding angles. Okay. So therefore, now what is r sine theta? Now what I will do is, let us take up one of this line. I'll take r1 here, drop a perpendicular here. When I drop the perpendicular, this triangle, which is this is O, this is A, this is B. Okay. Now, what is AB? AB is equal to R1 sine theta. Am I right? AB is equal to R1 sine theta. What is AB here? AB is nothing but H. H is equal to R1 sine theta, right? So if I am asking you to find out what is the angular momentum at this point, you will say this R1 into sine theta into M into V. So therefore, now I can now write this as MV into H. Are you getting me? Right? This will be R1 sine theta MV into H. If I consider one more vector, let us say, for example, if I take up this value, now what is this now? This distance is R2 here. Now what is this now? This is AB over here. Let me write this as some A dash B dash. A dash B dash. Now let us do the same thing. Now I have A dash B dash is equal to A dash B dash divided by R2, opposite by hypotenuse. Now this will be your angle. This definitely is not theta. It's some alpha. Okay. Should now be equal to R2 sine alpha. R2 sine alpha. Now your angular momentum once again would be L is equal to MV. Let me write L2 here. I have written L1 here, L2 here, MV. See, V is not changing, okay, for this particle, into R2 sine alpha. So now I can substitute this A dash B dash. What is A dash B dash once again? The vertical height H. Vertical height H. So which would now once again be equal to MV into H. So you see L1 is equal to L2. See, now when the particle is here, it had a momentum, angular momentum L1. When the particle is here, angular momentum L2, but L1 is equal to L2. Now if I extend my argument like this, once again, if I put this as A dash, A double dash, B double dash, even then I'll get the same angular momentum, which means the angular momentum at any position, whether it is 5 seconds, 10 seconds, whatever it is, this is always equal to MVH. I hope you got this problem. The question can be asked in a different way. If it is for IBDP problem syllabus, we can ask the question as, will the angular momentum, what will be the change in angular momentum, okay, over time? I can ask it like this. Or I can also ask you something like, what is the rate of change of angular momentum? What is the rate of change of angular momentum? So, which is delta L divided by delta T. Okay, we can ask also this one. What will be the answer for this? This will be equal to, first one, this will be L2 minus L1 divided by T2 minus T1, delta T. Now, what is L2 and L1? They are equal. So, therefore, this should be equal to 0. Now, I'm going to give you a new concept here. Okay, in addition to this problem. The concept is, what is L? Angular momentum. If it in rotation, you call it as angular momentum. If in kinematics or in forces, what did you call it as? You remove that angular and you put a linear there, right? So which means this value is nothing but your delta P in kinematics. And delta T, there is no angular time, there is only linear time. So therefore, this is delta T. Now, delta P by delta T equal to 0. What do you mean by delta P by delta T? Delta P is nothing but force here, right? Force equal to 0, which means what? When the force equal to 0, the particle is moving in a constant speed. Now you see, it's moving in a constant speed. Okay. In a similar way, when the net angular momentum, rate of change of angular momentum equal to 0. Now, corresponding to force, what is there? What is that you learn in rotation? You call this as torque. When the net angular momentum equal to 0, when the net torque is equal to 0, then also the particle moves in a straight line. Okay. So this is what we have got. So far we have learned that whenever a particle is moving in a straight line, then with respect to the origin, the angular momentum is seen to be a constant and the net torque is equal to 0, which means there is no rotation being observed. I hope you understood this problem. So if you really like this video, do share and subscribe to my channel for more updates. It would really help me to do more number of problems. And if you have any other questions based on this, you can always write to me. So my email ID is over here, which is ratankar@gmail.com, which is over here. Okay, you can also visit my website to see at my services. I do offer services as a one-on-one coaching for either of these classes like JEE, IBDP, IGCSE, ICSE, or CPSE. And most probably, preferably, I love to solve problems, numericals, okay, rather than teaching only the concepts. And then I also do internal assessment guidance for IBDP, project guidance for physics, and basically I'm a bioinformatician. Okay, apart from being physics, my doctorate degree is in informatics. I do guide students for PhD and MTech students. Thank you, friends, for watching. Like, share, and comment on my video to get more updates. Thank you.